Welcome back to USMLE High Yield Bites. Today we are going to tackle the vomiting center. It is a very big topic when it comes down to target the drug questions. Master this and you will be all set for the high yield vomiting scenarios. All right, let's do this. Let's break down the vomiting center, a high-yield topic for neuroanatomy and pharmacology. There is going to be a lot of tongue twisters here. So first, let's talk location and coordination. The vomiting center is orchestrated by nucleus tractus solitarius, or NTS, in the medulla, a key fact for USMLE Step 1. Its primary input comes from the chemoreceptor trigger zone, or CTZ, located in the area postrema near the fourth ventricle. Why does this matter? The CTZ lacks a blood-brain barrier, making it super sensitive to drugs and toxins in the blood or cerebrospinal fluid, which is a classical USMLE test point. Now let's look at the inputs to the vomiting center. It receives signals from GI tract via the vagus nerve. Think irritation and distension. The vestibular system sends emotion-related signals, which explains motion sickness. The CNS, including higher brain centers, contributes emotional or stress-related triggers, and the CTZ itself detects emetogenic substances like chemotherapy drugs. For step 1, you will need to know these pathways because they tie directly to pharmacology questions. For example, the CTZ's role in detecting toxins makes it a target for the antiemetics like ondansetron, which we will cover in the next slide. Here, your high-yield takeaway. The CTZ is the area postrema, is your go-to for pharmacology and pathology questions, especially chemotherapy-induced vomiting. Memorize the NTS and CTZ locations, and you will be ready to tackle those neuroanatomy questions with confidence. All right, now let's dive into the receptors and pharmacology of the vomiting center, crucial for the USMLE Step 1. The chemoreceptor trigger zone and vomiting center work through 5 major receptors. First, histamine H1 receptors are involved in motion sickness and hyperemesis gravidarum. Muscarinic M1 receptors also play a role in motion sickness. Neurokinin, NK1, and dopamine D2 receptors, along with serotonin 5-HT3 are key for chemotherapy-induced vomiting, while 5-HT3 also ties to postoperative nausea. Now let's talk high-yield treatments. For chemotherapy-induced vomiting, you will see 5-HT3 antagonists like ondansetron, D2 antagonists like metoclopramide, and NK1 antagonists like aprepitant motion sickness. Go for H1 antagonists like diphenylhydramine and M1 antagonists like scopolamine. For hyperemesis gravidarum, H1 antagonists like doxylamine and are your go-to. Here's a step 1 tip. Match the receptor to the clinical scenario for quick points. Memorize ondansetron for chemo and scopolamine for motion sickness.